Zinc deficiency is widespread in low-income countries due to the low nutritional zinc intake. Lack of zinc leads to immunity and growth dysfunctions. Supplementation and fortification of local cereals are promising strategies to combat zinc deficiency. When developing zinc-rich products, it is however important to first assess the bioavailability of the added zinc. The most suitable method to measure zinc absorption is the so-called double isotopic tracer ratio technique. For this purpose, the administered zinc must be labeled with a tracer whose processing in the body can be monitored. The tracers are, in this case, two stable isotopes of zinc. Isotopes are variants of a particular chemical element. The zinc present in the nature has the average atomic mass of 65.38. But it is actually composed of zinc variants or zinc isotopes with atomic masses of 64, 66, 67, 68 and 70. Some of isotopes are more recurrent, like the zinc isotope with the atomic mass 64. Others are very rare, like the zinc isotopes 67 and 70. These two rare isotopes can be used as tracers. To illustrate the technique for measuring zinc absorption, I will use the simplified model of zinc metabolism. It includes the intestine, through which the dietary zinc transits. From there, it is partly absorbed to the bloodstream and partly excreted. The absorbed zinc is then transported from the bloodstream to other compartments or excreted, for example in the urine. The ingested zinc, the supplement or the added to food, is labeled with a zinc isotope tracers, the so-called oral zinc isotope tracer, for example isotope 67. Once in the intestine, an unknown amount of ingested zinc is absorbed and enters the bloodstream. Thereafter, a second zinc isotope tracer, for example zinc 70, is injected directly into the blood. After a while, both tracers in the blood start behaving the same way. They are transported to other compartments or excreted. At this point, we need to collect a sample in which we can measure the two tracers. This can be done in the urine. Urine would naturally have the isotopic composition as in the table presented before. But now it is enriched with the two isotopes administered orally and intravenously. We can measure the amounts of the two tracers in the urine using a mass spectrometer. We now know how much of the intravenous tracer was injected in the blood and which percentage was excreted in the urine. We don't know how much of the oral tracer was absorbed from the intestine into the blood, but assuming that the oral tracer has been excreted from the blood to the urine with the same proportion as the intravenous one, we can easily calculate the amount of the oral tracer in the blood and the proportion of the absorbed zinc.